Okay, we're back with the next part of College Algebra Practice Test 3A. We did the first 10 questions on the earlier video, and now we're going to pick up with number 11 here. So the graph of f of x equals the square root of x, or in other words, x to the 1/2 power, we know goes through 0, 0, and 1, 1 in the first quadrant and is increasing concave down like that. Now, what about g of x, which is negative 1/3 square root of x? So this graph here for the square root of x is in blue in all four of these. Okay, so what happens here? Well, there's actually two things. So if we think of this as y square root of x, the first thing we can think of is minus y equals the square root of x, or y equals negative square root of x. These are the same. And notice what we've done is we've replaced y by minus y. That's going to reflect over the x-axis, and so it's going to be down here. The next, so we're going to end up with a fourth quadrant graph. So that eliminates b and c. So now we're down to either a or d. Now when we do this, we say 3y is minus the square root of x, or y equals negative 1/3 square root of x. So from here to here, we replace y by 3y, which really multiplies the y's by 1/3, or divides the y's by 3. And so that's going to make all the points closer to the x-axis than the blue graph. So the green graph should be closer to the x-axis than the blue one. So that means it's A rather than D. Next question. Describe how the graph of h of x is 1 over x plus 6. So you want to think of that, it's y equals 1 over x plus 6. So that's y minus 6 equals 1 over x. So compare that to y equals 1 over x. We've replaced y by y minus 6. So what do you really do? You add 6 to all the y's, so you're going to shift it up 6 units. So D was the correct answer there. And so what does that look like? Well, this one, y equals 1 over x, looks like this in the first quadrant. That's x to the negative 1 power. We know those power functions look like that. And then in the over here in this quadrant, we're going to get the third quadrant reflected over, rotated around, has origin symmetry. So roughly like that. And if we just shift it up 6, then this horizontal asymptote now is going to be up at y equals 6, and then it's going to be here and here, kind of like that. So if you look over here at the let's see, at the possibilities, looks like A is the correct one there. C is more like the original one, and then 1 over x, and B is shifting the wrong direction. Okay, next, 13. Okay, so 13, we're going to compare to the base function y equals absolute value of x, which we've done this one enough. We know it's a slope negative 1 here, slope positive 1 here, kind of a V shape there, and the blue graph is the same in all those. Now we want to think about this one, g of x, or just y, equals negative 1/2 absolute value of x minus 3. So we want to think of this in stages. So which one is going to be the right one? Well, let's see here. How do we get from here to here? Let's do it in steps. So let's do the negative first. So y equals negative absolute value of x. Well, that's the same thing as negative y equals absolute value of x. So we've changed the sign on y, which is going to take the graph and flip it over the x-axis. So it's pointing down like that. Okay, then we can take it and let's get the 1/2 in there. So minus 1/2 absolute value of x equals y, or in other words, 2y equals negative absolute value of x. So if you see it that way, from here to here, we replace y by 2y. What does that really do? That really takes the y's in half. So now it's going to be half as big. So these are going to have not as steep here. Okay, so that gives us that. So now the last step is y equals negative 1/2 absolute value of x minus 3, which we can think of as y plus 3 equals negative 1/2 absolute value of x. So from this one to here, we've replaced y by y plus 3, which means you really go down 3. So this should be at negative 3. It's going to look kind of like this. So which one looks like that? Looks like D is the only one that's going to look like that. So there we go. 14. 14. There we go. F of x equals x to the 10 over 23. Okay, well, let's think about what this graph is going to look like. First of all, it's a power function. It's just y equals x to some power. Now that power, 10 over 23, is between 1 and 0. So it's a positive power. All power functions, if they're just basic power functions like this, are in the first quadrant. A positive power, so it's going to go through 0, 0, and 1, 1. And it's going to increase. But the power between 0 and 1 says it's going to increase in a concave down manner, so it looks roughly like that for the first quadrant. Now we've got even over odd, so let's see what that does to a negative. If you put a negative and raise it to the 10th power, that becomes positive. Then you take a root, it becomes positive. So it's going to go through negative 1, 1, and we're going to end up having a mirror image like that. Okay? So let's answer the questions. What's the domain? Well, it should be all reals. That's B in this case. What is the range? Well, it goes from 0 to infinity, including 0, so that's C. It's in quadrants 1 and 2. It has symmetry about the y-axis. In the first quadrant, it's increasing concave down. And on the extreme right, it is going up forever, so it increases without bound. And the graph here is all one continuous piece, meaning it's all connected. There's no break. Okay, next, 15. Oh, here it is. F of x equals x. Well, y equals x, we know what that is. That's just a line with slope 1. Goes through the origin like that. So the domain is all reals. The range is all reals. That's B here, D there. Negative infinity to infinity. It's in quadrants 1 and 3. It has origin symmetry. It's increasing linear everywhere. It increases without bound going to the right, and it's one continuous piece. That's a power function that's kind of by itself. It's the only one that's a solid straight line. 16. Okay, so in general, if we have a function y equals x to the n, or f of x equals x to the n, where n is a constant, that's what we mean by our power function. If n is greater than 1, then the first quadrant will be, okay, so in general the size of n is going to tell you what happens in the first quadrant. We always know positive to any power is positive, so we're going to get first quadrant on all these basic power function graphs if they haven't been transformed. And the size of n is going to tell you what the shape of the graph is in the first quadrant. If n is bigger than 1 in the first quadrant, it's going to be increasing concave up, going through 1. They all go through 1, 1, and 0, 0. Well, 0, 0 if it's positive, it goes through 1, 1 no matter what. So there's the first quadrant if n is bigger than 1, increasing concave up. If n equals 1, then the first quadrant still goes through 0, 0, and 1, 1, but it's straight. So it's a straight line there, increasing linear. If n is between 0 and 1, okay, it's still positive, so it's still going to increase. It still goes through 0, 0, and 1, 1, but it's going to increase in a concave down manner, like that. If n equals 0, it's constant in the first quadrant, right at 1. In fact, it's y equals 1 everywhere except for right at there at the x equals 0, which has a hole in the graph. So it's constant and linear there in that case. Now for the negative powers, where n is less than 0, in the first quadrant it still goes through 1, 1, but it's concave up and decreasing, and it has the asymptotes of the x-axis and the y-axis right there. So all the negative powers look kind of like that on the power function. So that's decreasing concave up. Now, if it's a rational power, it's a power p over q, where p over q is reduced, then if you get odd over odd, whatever it does in the first quadrant, you're going to have the third quadrant too. So this is quadrant 1 and 3, and it has origin symmetry. If it's even over odd, okay, now let's just think about what's going to happen here. This is going to have 1, 1 in it, they all do. But odd over odd, if you plug in negative 1 to an odd power, you get negative 1, and then our odd root's going to be negative 1. So it has negative 1, negative 1. So that kind of helps tell you that it's going to be quadrant 3. Of course, this one has quadrant 1. Obviously, they all have that. And it's still going to go through 1, 1. They all do that. But what happens when I plug in a negative? A negative to an even power is positive, and then an odd root is positive. So negative 1 is going to go to positive 1. And so you see you're going to get quadrant 1 and 2, and you're going to have y-axis symmetry. Even over odd. That was this one. Okay? And this one's odd over even. Okay? And then, of course, it's going to have quadrant 1. But what happens here is you take a negative to an odd power, you get a negative, and you take an even root, you don't get a real. So this is only first quadrant and not necessarily any, well, no symmetry may be a little strong, but it doesn't have x-axis or y-axis symmetry or origin symmetry. Now, if you have a power that's an irrational number, you can't make it into a fraction, then it'll also be quadrant 1 only. So in other words, we're not going to define like negative 1 to the pi power. Okay, so here's one, x to the 55 over 34. So put these ideas together. 55 over 34 is actually greater than 1. So we know in the first quadrant it's increasing concave up. And we got odd over even, so that's it. That's all we have. So it has an endpoint here at the origin. So the domain is 0 to infinity, including 0. The range is also 0 to infinity, including 0. There we go. It's in 1 only. It doesn't have origin, y-axis, or x-axis symmetry. It's increasing concave up in the first quadrant and increases without bound on the right, and it is one connected piece. It just doesn't go. It has an endpoint there. It doesn't go any further to the left. Okay. Alright, now we're going to switch gears a little bit. Go to solving an equation with a radical in it. Cube root of 2x plus 8 and then plus 9 equals 2. The way to solve these by hand is to get the radical by itself. So we're going to subtract 9 from both sides. It's going to give us negative 7 here, and it gets this cube root by itself. Now we're going to take this and take both sides and cube them. So the cube root and the cube will cancel, and negative 7 cubed, let's see, 7 times 7 is 49, times another 7, that's 63, carry 6, 28, 34, so it's 343, and there's 3 negatives altogether, so it's negative 343. Subtract 8, 2x equals negative 351, and divide by 2, x is negative 351 over 2, and that's correct. Now, it's a good idea to check these, particularly if you raise to an even power, you have to check them. And this one, if we didn't make any mistakes, we're okay, but let's check it anyway. 2 times negative 351 over 2 plus 8 cube root plus 9 is supposed to equal 2. Here the 2's cancel. Negative 351 plus 8 cube root. Alright, let's see what we get here. This is negative 343, and we just saw that that is negative 7 cubed, so the cube root, that's negative 7. Negative 7 plus 9 is 2. 2 equals 2, so that checks, which is what they have here, so that's good. 20. Absolute value of 2 minus 4x less than or equal to 1. Okay, so if the absolute value is small, that means the number is close to 0 on a number line. So it's how close? Well, no further than 1 away. So that number, 2 minus 4x, the thing we're taking the absolute value of, has to be between negative 1 and 1, because remember the absolute value is the distance from 0 on a number line. Now we can solve this by subtracting 2 from all three sides of the equation. Subtracting 2, okay. Now when I divide by negative 4, that reverses the inequalities, and negative 1 divided by negative 4 is 1/4. This is 3/4. So normally we'd write that the other way, set of all x such that 1/4 is less than or equal to x is less than or equal to 3/4, or a better way is just use interval notation, 1/4, 1/4 to 3/4, including both. And that'll be graphing a closed interval between 1/4 and 3/4. Looks like D is the correct one, and you can see the solution set there. Now remember, put these in, you're going to be using some of this stuff here on the side. Okay, you might need to use the bracket from your keyboard, and then enter fractions and so forth. Okay. Okay, there's the next 20. We'll do the rest of the test on the next video.